Hi everyone, so today is day 23 of September LeetCoding challenge, and on this day we'll be solving this problem, break a palindrome. So as the name suggests, we will be breaking a palindrome in this problem. So in this problem, we have been given a palindromic string, and it is consisting of lowercase English letters palindrome. So in this palindrome, what we have to do, we have to replace exactly one character. So we are not allowed to replace two characters or three characters. We have to replace only one character with any lowercase English letter. So we have to with English deal with English lowercase English letters only to solve this problem. And after replacing, the resulting string should not be a palindrome, and it should be a lexicographically smallest one possible. So there are two objectives we need to achieve after replacing. So first thing is most important thing is that we need to turn this palindrome into a non-palindrome, and we can achieve this first thing with a lot of ways. So of all the ways possible, we need to return the the string, resultant string, that is the lexicographically smallest string possible of all the resultant strings. And it is also possible that we cannot change the current palindrome into a non-palindrome by replacing one character. So in that case, we have to return an empty string. And there are some examples. So the first example is that the palindrome is ABCCBA and the output is AACCBA. So we can see that the second character was changed to A, and there are a lot of ways to make this ABCCA not a palindrome. So one was replacing the first character with Z. The second character, the second way was to replace this B to A. So this is the one that is the answer. And the third one was to change this C into A. So these are the three ways, and actually there are more ways also. So these are some sample ways, right? So of all these three, we can see that this AACCBA is the lexicographically smallest. So the reason why this is the lexicographically smallest, because this one is starting with Z. So obviously, like, the one starting with A will be this lexicographically smaller than that. So this is the lexicographically largest of all these three, right? So we can neglect this, like eliminate this. Now the competition is alive between these two. So in the first character is same in both. The second character is differing. So here it is A, while here it is B. So this one will win because it is having a smaller character as compared to this string, right? So we can see that if we are like targeting the like leftmost character as leftmost character as possible, then we will be able to achieve more impact on the lexicographicality, because like if we are changing, if there is Z here and if there is Z here, right? So this Z will make more impact on deciding which is lexicographically smaller or larger than this Z, because for deciding which one of them is lexicographically smaller, we first find the character which is differing in the two strings. So if we are able to make the difference on the leftmost character as possible, then like we'll be able to achieve the goal. So after seeing some examples, we will move how we will be solving this problem. So we can take an example too. So in this example, like the palindrome is A. So the palindrome is actually a one character string, and we know that every one character string is a palindrome. So in this example, like, we cannot replace this existing character A to any character, so that the resulting string is not a palindrome. So that's why the output is an empty string. And the third example consists of a string containing A. So we can like turn this second A into B to get the answer AB. And here the like palindrome is ABA. So we are like changing the last character to get ABB. And now moving to constraint, so we can see that the palindrome length is at max 1000. So seeing the constraints, we can see that an order and squared solution will also be able to pass all the test cases. But actually the problem is quite easy. So we won't be implementing a order and squared solution. We will be using a order and solution to solve this problem. So now let us move to the approach how we'll be solving this problem. So they, let us first assume that the number of characters present in this string is n, right? So if n is equal to 1, so this is this case, right? When there is only one character in the palindrome. So in this case, it is not possible to turn it into a non-palindrome. So we'll be returning the empty string in this case. So now there are two types of n. So it may be possible that n is even and n is odd. So if n is even, then we can divide the whole palindrome into two parts, left part and right part, right? So this every character in the left part has got a corresponding character in the left part, right? So if we'll be changing any character on the left part, then obviously it will violate the condition of being a palindrome. So we will be able to achieve our goal of turning it to a non-palindrome. So of like now we have got a lot of characters in the left part that we can change. So we know that if we will be like targeting the leftmost character, so if we will be changing this character, leftmost character into the smallest character possible, so obviously the smallest character possible will be a, and then we'll be able to achieve the lexicographically smallest string. So we can always like convert any character present at this place into a if on like if this the present character present on this leftmost character position is not a. So if it is a, then we cannot do so. So because replacing a with a won't be called a replacement. So if there isn't any character a like equal to a present here, then we can change this character into a, and since we have made one replacement, that will be the answer. And if it is a, then we will move to the next character, and if it is not a, then we will change this character into a, and if it is a, then we will try the next character. So what will happen if all the characters are a? So in that case, all these characters on the right side will also be a. So basically that would be the case when the whole string is made of only a's. So now we need to, so actually this string is lexicographically smallest string of this length. So we will, the result, the answer that will be forming will be always be lexicographically greater than this string. So for making a result, we will be trying to make as much as small as lexicographically small character string as possible. So how will we achieve this? So we know that if we'll be changing this a into b, it will make it much lexicographically larger. So we'll be targeting the last character. So we'll be changing the last a into b in that case. And what if the n is odd? So in that, if n is odd, then the n by 2 characters, considering the floor division, will have 1-to-1 mapping on the right side, and this one character will not have any mapping, right? So if you'll be changing this one character in the middle, it won't break the palindromic condition, and this string will remain a palindrome. So we won't be changing this string. So we'll be again targeting this first part, and if all these strings, all the characters in the first part are a, then what we'll be doing? We will be doing same thing. We'll be changing the last like the character on the rightmost position to b to achieve the answer. So this is the algorithm that we'll be using. So we can get rid of all these things because we are now going to implement this solution. So implementation is quite simple. We'll be starting by storing the size of the palindrome. If n is 1, then we will be returning empty string, and now what we need to do, we can iterate over the left part. So the left part is from index 0 to not including n by 2, right? So if that pal- so if that present character is not equal to a, right? In if in that case we can change this character into a, and now we are done. So since we have made one replacement, we'll be breaking. And if it is not a, if it is equal to a, we'll be like trying the next string. And if we have done one replacement, then obviously the palindrome we have now present after exiting the loop is the answer. And what if all the characters are a? So how will we know we have made a replacement or not? So we'll be using a variable boolean, right? So this boolean, I will call it replaced, is replaced. So this boolean will tell me whether the palindrome string has been replaced with one, like replaced. This boolean will tell me whether any character of the present string has been replaced or not. So initially this string has not got any replacement, so it will be false. And if I'll be doing any replacement, I will set this is replaced boolean to true. So if no replacement has been made, then what we can do, we can set the last character of the palindrome to be. So how can we get the last character? That will be palindrome n minus 1, and we can set it to be. So after doing all this stuff, the palindrome we will be having will be the answer. So yeah, so this code will be sufficient, and the time complexity is order n, the space complexity is order 1. So we can try to run it on the sample test cases to check whether we have made in compilation errors or not. So yeah, I have misspelled this palindrome thing. I think it should work now. Let us try again. Like it is taking too much time. I don't know why. Yeah, so it is working. We can submit it. Yeah, it got accepted. So thank you guys. We will be now meeting on day 24. Until then, keep leet coding.